Hello there and welcome again to Cambridge Advanced Level Mathematics. Today I brought you an exciting and short question from paper 1 of 2020. It's question number 3, which reads as follows. The 13th term of an arithmetic progression is 12 and the sum of the first 30 terms is minus 15. Find the sum of the first 50 terms. Let's read it again. The 13th term of an arithmetic progression is 12 and the sum of the first 30 terms is minus 15. Find the sum of the first 50 terms. There are two things here that we need to know before we can be able to answer the question. Number one, we need to know the general term, the formula for the general term of an arithmetic progression. Number two, we need to know the formula for the sum to n terms of an arithmetic progression. So let's look at these in turn. The first one will be the general term. I'll give you a nice and simple example of an arithmetic progression. It can be 1, 3, 2, 1, 3. I don't know why I'm going down with it instead of going up. So 5, 7, 9, and so forth. Now, this is a series in which the one number differs by a constant from the one that is next to it. For example, here, 3 minus 1 is 2. 5 minus 3 is 2, 7 minus 5 is 2, 9 minus 7 is 2. This 2, which is a constant, the difference between one term and the one next to it is called the common difference. Common difference. I'll just write it D for short. And it's denoted by the letter D. Now, the first term of the series is denoted by the letter A. So, first term is equal to A. Okay? In this case, our first term is 1, and we discovered our common difference is 2, which is D there. For example, supposing we wanted to find out, so what is the general term of the series? The general term of the series is given by A plus n minus 1 D. Okay? Supposing we wanted in this progression to find the 1, 2, 3, 4, 5, the fifth term, then we would say, okay, the fifth term will be A is 1 plus our fifth term n is 5, so 5 minus 1, which is 4, multiplied by our common difference, which is 2. So it's 4 times 2, which is 8, plus 1, which is equal to 9, which is the 9 that you get. And so on for any other term there. So you can get it by using the formula for the general term. What about the sum to n terms? If we wanted to sum n of those terms, the formula is n over 2, where n is the number of them, multiplied by A plus L, where L would be the last term that we want to sum up to. Okay, so this is one formula. We know, of course, that our L can be expressed in terms of the general term of the series. So we know that L is equal to A plus n minus 1 D, if L is the nth term. So we can replace our L there with this formula, and we get Sn is equal to n divided by 2 multiplied by A, this A here, plus that A there, A plus n minus 1 D, close bracket. We can add those two guys. It's n over 2, big bracket, 2A plus n minus 1 D. That's an alternative formula for the sum to n terms. Of course, which one you use depends on which information you are given. If you are given the first and the last term, this is the one to use. If you have got your common difference and your first term there, this one will suit you. Okay. That makes us ready to tackle the problem. So before we do that, let's just put these little formulas in a corner there somewhere, because we would like to refer to them as we go. So remember, we said that our sum to n terms can be n over 2 multiplied by a plus l, or it can be n over 2 big bracket 2a plus n minus 1 multiplied by d, close bracket. So those are the two formulas. We'll find out which one will do for us in this particular example. Okay, so there we are now. They are saying the 13th term of an arithmetic progression is 12. Well, what is the 13th term? We know that the general term is a plus n minus 1 multiplied by d. A, we are not told, we don't know. But n in this case we are given, it is 13. So 13 minus 1 gives us 12. Our d we don't know. So we can write a plus 12d is equal to, we are told it's equal to 12. Let's call this equation number 1. The next piece of information there is we are told the sum of the first 30 terms is minus 15. The first 30 terms, we better use this one. We are not told the last term. Let's put this one aside. We will use this one. So we can say we are given the first 30. So n is equal to 30. And 30 divided by 2 obviously is 15. So we can write 15, big bracket, 2a plus, here it's 30 minus 1, which is 29d. Do you follow that? Our n is 30. So there we get a 15. Here is 30 minus 1, which is our 29 there. And what is this equal to? We are told it's minus 15. So we can write this is equal to minus 15. Right. Surely we can divide right through by 15 and say 2a plus 29d is equal to 15 into minus 15, that's minus 1d. So now that is equation number 2. Let's get rid of a here. We can have, therefore, a is equal to, from equation 1, a is equal to 12 minus 12d. So substituting now for a in this equation 2, we have 2 brackets 12 minus 12d plus 29d is equal to minus 1. Let's simplify. We have, this is 24 minus 24d plus 29d is equal to minus 1. Let's simplify our d there. So it's 29 minus 24, which is 5. So on this side, we can have our 5d. 5d, let's take the 24 over to that side. It becomes a minus 25 because minus 1 minus 24 is minus 25. Divide right through by 5, we get our d is equal to minus 5. Okay, so d is equal to minus 5. What about our a? Our a is equal to 12 minus 12 times minus 5, which is equal to 12 minus 60, which is plus 60, and that gives us 72. So a is equal to 72, and d is equal to minus 5. So let's just put it here in a little corner there. So d is equal to minus 5, a is equal to 72. Okay, 72. Let's keep that there. Now, our objective is to find the first 50 terms. Okay, now that we've got our D, we've got our A, we can very comfortably use that formula there. So now all we need to do is to plug in the numbers. So our N, of course, is 50. So S50, let's call it S50, is equal to 50 here divided by 2 is 25. Let's put a big bracket. 2 multiplied by A is 144. 72 times 2 is 144. Now here we have an 50 minus 1, which is plus brackets 49 multiplied by what? D is minus 5, so it's minus 5 there. Then we close our bracket. Let me see what we get there. So this is 49 times 5, which is 245. 245. So we have here 25 multiplied by 144 minus 245. What is that? That gives us minus 144, which is that 101. 101. It's actually a minus. So we have 25 multiplied by minus 101. Because 144 minus that is minus 101. And that should give us times 25, which is 2,525, which is minus 2,525. That is the sum to the first 50 terms. You can also try using this formula. We know that, okay, if there are 50 of them, let's see if we can use it and come to the same conclusion here. I'll put this sum there somewhere. So it's minus 25, 25. That's the sum to the first 50. We used this formula. We want now to try and use that one and see if it gives us the same result. Of course, we know our A is always 72 there. So, but what is the last term? The last term is given by A plus N minus 1 D. Our A, we said it's 72, and there are 50 of them, so this is 49 multiplied by our D is minus 5. So that gives us what? That gives us 49 times 5, which is 245, minus 72, which is that. So the 50th term is minus 173, because this is bigger than that, right? So subtracting the smaller one from the bigger one. So that one is there. So when we come over here, we can now say, therefore, our sum will be N is 50 divided by 2. Our A is 72. And then our L is minus 173. Okay? So, subtract there. Of course, this is just 25. This is our 25 there. Multiplied by, let's calculate that, 173 minus 72, which is that, 173, 173 minus that, which is 101. Okay, it's 101. We can just do some, 3 minus 2, that's 1. 7 minus 7, that's 0. 1 minus 0, that's 1. It's negative, of course. Multiplied by that, it still gives you a minus 25. So it doesn't matter which one you use, as long as you've got the information, you can use this one. If you have got information for this, you can use this, but they all give you the same result. That's all for today. Till see you next video. Bye-bye.